Okay, so this is the introduction to arithmetic sequences and series. The way I'm going to work this is I'm going to go through the entire thing here in this video and go through all the examples all at once. I will also do some separate recordings where I do it piecewise for your assignment, and I will probably explain that in class or on a video. So here we go. In an arithmetic sequence, is like this right here. I've written out an arithmetic sequence on the right hand side, 4, 9, 14, 19, and then the 3 dots on the end, which is called an ellipsis, means that this pattern continues on forever. Each one of these numbers in the sequence is a term. So the first term is 4, the second term is 9, the third term is 14, and so on. So the way we would label these, this first term, T, term 1, first term subscript, and there's 4. And then our second term is T2, and that would be 9. And it's pretty easy to see that the pattern is that we add 5 between each successive number. Okay? So the difference, remembering in math, the difference means subtract. So the difference between 9 and 4, 9 subtract 4 is 5. And each term has 5 between it. So there's a common amount or a common difference between each term. So that common difference, which we call D, for this one is 5. Now it's fairly obvious for this one. If it isn't obvious, then what you would do is take the second term and subtract the first term, and you would get your common difference. So what I have to the left here is what's called the general formula for an arithmetic sequence. And so this works in every case. If I want to be able to figure out what any term is anywhere in the sequence, I can use this formula where it says any term, n, can be found by taking the first term plus your common difference onto n minus 1. Now, in most textbooks, you'll find this formula, but the D will be on the end of the brackets. I just kind of like to have it on the front. So there's the difference between the way that I prefer to do it and the way the textbooks do, but it's the same thing either way. So let's go through a couple of examples. First of all, the recursive formulas. Let's find the first 4 terms determined by the following recursives. So we already have the first term. The first term is 7. I need to find the next 3. I've got a formula right here that tells me how to find the next term. So if I want to find the second term, n being 2, or second term, let's say my T2 is equal to T2 minus 1 plus 4. 2 minus 1 is 1, so my second term is equal to T1, my first term, plus 4. So my T2 then is equal to the first term, which is 7, plus 4. So my T2 then is equal to 11. As soon as I see that, I could keep on going through the same pattern. You would quickly figure out that in order to get the next term, T3, I would take the previous term, n minus 1, previous term, and add 4. So my T2 was 11. So 11 plus 4, so my third term is 15. And since this is arithmetic, it means we're going to add the same thing every time. So it looks like we're adding 4 every time. So I get 19 when we do that. Erase that to give myself a little bit of space. Alright, our next one, a little different here for this one. This is a recursive formula. We'll see if the series or the sequence actually ends up being arithmetic or not. So my first term is 2, so we can write that down. And then I need the next 4. So to get my second term, T2, I'm going to go 3 times. And here you see this a lot in math. It's going to be your previous term. N minus 1 means your previous term. So I'm just going to skip the filling in the 2 minus 1 part and make it say T1 and minus 2. So then my second term is equal to 3 times T1, which is 2, minus 2. So my T2 then 6 minus 2 gives me 4. Let's figure out our third term. Again, it's going to be 3 times my previous term. So my previous term now is the second term. Previous to T3 is T2 minus 2. So for T3, I end up with 3 times 4 minus 2. So then my T3, 12 minus 2 gives me 10. So you can see that this recursive formula doesn't actually give you an arithmetic sequence. There isn't a common difference between the terms. Okay, so we'll finish this pattern and we'll figure out T4. It's going to be my previous term, which is T3. 3 times the previous term, which is T3 minus 2. So T4 is going to be 3 times 10 minus 2. So my fourth term is going to be 30 minus 2, which is 28. So another thing I'm going to do that goes along with this course is I will actually save these notes and put them up as a PDF. So if you want to just follow along with the video, then you can. The other thing, if you're taking your own notes, I'm going to go quickly through these and you can just pause because I'm not going to really give enough time to stop and catch up to me writing. So just pause the video if you need to. All right, next one. It says find the fourth term for each of the following sequences. So I've only got one sequence up here. You're given the first 2, and now I have this more complicated formula. So my first one is 1. The second one is 5, and I need the next 2. So I need to find T3. So to find that, I'm going to use my formula here. Right? So it's going to be 3 times previous term. My previous term is 5. There's my T2. Here's my T1. So my previous term, so it's going to be 3 times 5. Actually, let's fill that formula so you can see it a little better. So this is going to be my previous term, T2, minus whatever my 2 terms previous, k minus 2. Right? So if I'm doing the third term, then it's minus this term. So for my third term, then it's going to be 3 times my second term, which is 5, minus my first term, which is 1. So if I do that, 3 times 5 is 15. 15 minus 1 gives me 14. So fill that in. One more term. T4, it's going to be 3 times the previous term, so times the third term, minus 2 terms previous to when I'm figuring it out, so 2 terms before that is T2. So if I do that, my fourth term is going to be 3 times T3. T3 is 14, minus term 2. Term 2 is 5. Fourth term becomes, well, 3 times 14 gives you 42. 42 minus 5 gives you 37. All right, next one. This time I'm giving you a sequence and asking you to actually write down the general formula. So that's the one that we had earlier. Here, that's the general formula for the arithmetic sequence. So I need to have the first term and the common difference. Now you'll see with these simple ones, it's going to be pretty straightforward. So I write down the general formula as Tn is equal to T1 plus D 1 to n minus 1. That n minus 1 part always stays the same. So for me, Tn equals, my first term is 15, so that's easy enough. There's 15 plus common difference. So how much do I add or subtract to each term? So technically it's adding every time. How much am I adding every time in order to get the next term? So you can easily see them adding 15 every time. So my common difference here is also 15. This one, a little different. So again, I'll write down the general formula. Tn equals T1 plus my common difference onto n minus 1. So for this one, my first term is 40. And then my common difference, how much am I adding every time? Well, I'm adding a negative 7. Right? So there's a couple different ways you can write this. You can say plus a negative 7 onto n minus 1. But plus a negative means to subtract. So I'm going to write it as subtract 7 onto n minus 1. Fairly straightforward. This next one, the sequence define, okay, and it gives us a defined general sequence. Find each of the following terms. So I want to find the value of the third term. So notice in place of my n, there's now a number 3, telling me I'm finding the third term. Well, my n is 3 in this case, so I'm going to fill in 3 each place that I see n. So then T3 is equal to 7 plus 4, and I'm replacing the n with 3. So I get T3 is equal to 7 plus 4 onto 2. So my third term has a value of 15. For the seventh term, T7, I'm going to replace once again my n with 7. So my n becomes 7 equals 7 plus 4 onto n becomes 7. It's 1. So mental math here, 6. So 6 times 4 is 24. 24 plus 7 is 31. All right. Next one. Determine which term has the given value. And so what term number is 38 in this sequence? So here's where I have to actually come up with the formula first and then figure out which term value has, which term is the number 38. So we start out with our general formula, Tn equals T1 plus n d onto n minus 1. So my Tn is equal to my first term, negative 10, plus my common difference here, the difference between each successive term is 6, and n minus 1. Now, I know my term value is 38. So I want to say which term, which n value has a value of 38. So what I do is I replace the Tn with 38. I say I know the term value is 38. And that has to come from negative 10 plus 6 times however many terms I have n minus 1. So now all I have to do is solve for that n. So we need to get it all by itself on one side. So the first thing I'm going to do is rearrange everything, pull everything to the left-hand side so I have n by itself on the right. So add 10 to both sides. I get 48 is equal to 6 onto n minus 1. Divide both sides by 6. And then I will get that is 36, 42, 48, 8. N minus 1. Add 1 to both sides. And I get 9 is equal to n. So it was the 9th term. T9 is equal to 8. start with the general formula here. This is determine the first term, the common difference, and the general term for each of the following arithmetic sequences. So this one's a little different. It's not immediately intuitive to figure this one out. If you sat down with it long enough, you would probably be able to figure out how to do it. But we'll go through it here, and then after that, you can follow the same procedure after that. So, for this particular one, okay, I've got the 8th term and the 15th term. So I've got the 8th term is 10, the 15th term is 28. So I've added the same amount every time for 7 times. The difference between 8 and 15 is 7. So I've added a common difference 7 times to get from 10 to 28. Okay. So that means the difference between my terms is 18. And to get that amount of difference, to get the value of 18 or add a total of 18, I've added the common difference 7 times. So, after that, you say, well, let's just solve for n. So I divide both sides by 7. And so I end up with, and this doesn't reduce, so you just leave it as 18 over 7. Not a nice number. But that is our common, that's the, that should have been D, not N. We're used to having the eraser just be automatic, so we keep on doing that. It's my common difference, I wrote down wrong. So that's my common difference, D. So now it wants the first term. Ways you can do that, but the easiest way is to just go backwards 7 times. So go 10, subtract 7 of these values of the n. So 7n will give me t1, right? Because if this is my 8th term, if I go backwards 7 terms, there's 7 values of d, then I would get my first term. So I can go 10 minus 7 times 18 over 7, notice the numbers work nicely here, equals T1. So I get 10 minus, these cancel out, 18 is equal to T1. So negative 8 is equal to T1. So now the only thing I have left to do is write the actual general formula. That came from going Tn is equal to T1 plus D onto n minus 1. So B, my first term was negative 8, plus my common difference, which is 18 over 7, onto n minus 1. So there is the general formula. Now, hardest one of all right here. This time I'm not actually working with numbers, I have some variables. And it says how many terms are in this arithmetic sequence. A little hard. Probably the first thing to do is to say, what's my common difference? Right? So how do I get from one to the other? Now above, in these previous examples, it's pretty easy to say, all right, well, my second term is 30, my first one's 15.